This is my first YouTube video. Flip string to monotone increasing. And I have attempted it and I found the solution, so I'm sharing it with you guys. As a 61% acceptance rate, this is my first video, guys. So don't expect too much, but the idea with this problem is to first think of the brute force way, right? And I don't mean like trying out all combinations, like doing it recursively and flipping this 0 to a 1 and then seeing how that affects the latest. So like deciding to maybe flip, don't flip 2 choices 2 power n. No, I mean like one smart brute force way, right, is to know that we can only generate n possible strings. So what I mean by that is, if you have a string of 5, the only strings that follow the limit are 0, 0, 0, 1, 0, 0, 0, 1, 1, 0, 0, 1, 1, you're seeing my drift, 0, 1, 1, 1, 1, or all ones, right? 0, 0, 0, 0, 0 also works, right? You can have all zeros, or you can have all ones, you can have anything in between, right? And then you ask, like, how many operations does it take S to go to 0, 0, 0, 0? How many operations does it take to go to this, so on, right? So, and that would be like, what? Naively, if we do that, right, we would check every character and it would take n, and we do that again, so that'd be n squared, right? We can't do n squared because the constraint is 10 to the power 5, but another thing you can notice is if everything is 0, we just have to count the amount of ones, right? You have to do 2 flips. In this case, what do you have to do? In this case, so the amount of ones is 2. In this case, you have to count like the amount of ones in your first 4, because you know how to flip 4, and you have to count your like amount of zeros here after, like amount of zeros. So like it'll make more sense if we show it in maybe this example. Zeros, we start 0, 0, 1, 0, and we have to check in these first 2 zeros how many ones are there, 0, so we don't need to make any flips. In these 3 ones right here, how many zeros are there? We have to make 1 flip, right? We have to make 1 flip. So is there a way to let me ask the question. Can you notice what repeated calculations I might be doing between this and this? I'm counting the number of zeros. 1, 2, 3, 4. Sorry, counting the number of zeros in this thing. 1, 2, 3. Ones, right? 1, 2. And again, I count this. I count this one. I've already counted these ones in the last one, right? So I just need to count the number of ones up to my split point, right? If I split at 3, and then I need to count what? The number of zeros after my split point, right? I need to count the number of ones up to my split point, or before my split point, and number of zeros after my split point. So you might quickly realize this is just like a prefix one count, and this is like a suffix count, if you've seen these patterns before. So I can just consider all the potential split points and then do a prefix sum and a suffix sum, right? And so I'm just going to use a pattern that I've seen, I've used many times, which we usually do. Prefix 1 is equal to 0 times, so you set n is equal to s, n plus 1, 0 times n plus 1. For prefix, you lead it forward for I in range s, prefix 1s of I plus 1 equals prefix 1s of I plus I plus 1 if s equals 1, else 0. You can do suffix zeros very similarly, but instead you loop backwards. So you say for j in range length of s, minus 1, negative 1, negative 1. You say suffix zeros of of j equals suffix zeros of j plus 1 plus, like you're reading it the opposite way. You have your forward combination ready, and you're reading it like backwards. Plus 1 if s equals 0, else 0. And then you consider like what I mean by split point is you can you consider that there's no zeros, you consider that there's 0, 0, 1, you consider that there's 0, 0, 1, 1. Like this, the split point is one sec. Yeah, like your split point is here, your split point is here, your split point is here. So this is what, like this is, there's 0, 1, 2, 3, 4, 5. So you consider all your possible split points. So for like, I'll call it split point. And you say, the split point is what divides all the zeros from the 1. So it could start at length of s or n, and it could range to 0, right? Where everything to the right of it is 1s. The split point in range n, -1, -1. You just, like we said before, you can just take the amount of, you have to flip these amount of 1s if we did this correctly, and you have to take this many amount of 0s, and that will be your count. And then we can keep a running minimum. So min flips equals, we always started some like maximum, like if we could do like something like infinity. We know that at max, right? At max, you would have to flip all of them. So 10 to the power 5. So you can make min flips like 10 to the power 5 plus 1. And then we can do min flips equals min flip. Whatever this is. And then I can return min flips to the end. Let's see if this gives us the right answer. Range. Did I put a string in? Yes, I put a string in. I can just say n. I can just say n. What did I do wrong? Let's see. Are we like off by 1? 0, 2, 0, 2. We always get 0. So now I'm confused. Let's check quick delay then. Right? Let's try this. 0, 0, 1, 1, 0. Let's see. So your prefix would be, you'd start at 0, then you'd count it is, like the next one would be plus 0 plus 1 only if s is 1. Is this, if s is 1, we found a problem. If s of I is 1, and if s of I is 0. Run it again. 2, 1, 3, 2, 0, 0, 5. Okay, weird. Let's side dial just with the first case. 0, 1, 0, 1, 1, 0. Again. Okay. So 0, 0, 1, 1, 0. And we say prefix of, the reason might be when you multiply it, if you change 1, everything else changes. Let's see. I don't think this is the issue, but let's try. No, that's not the issue. 0, 0, 1, 0. So your prefix 1s, it starts at 0, and prefix ones of 1 is 0 plus 1 if it is 1. Is this one? No. Same the next one. Is this one? Yes. Is this one? Yes. Is this no? But this will still be 1. Right? This will be 1 plus 1. This will be 2, and this will be 2. So prefix 1s seems perfectly fine. Let's see what we have for the suffix. So we have already a 0 at the end, right? We have a 0 at the end, and then we're just leading backwards. So suffix 0 is j plus 1 if it is 0. It is 0, so 1. It is not, so we'll get 1. We'll get 1. We'll get 2. We'll get 3. Okay, so the suffix zeros is that. And then we're saying for split point in range n. So, okay. So n would be this indice. So is that right? Is that right? Yes, there's 2 1s and there's 0 zeros. Yeah, so we get 2 plus 0. That'd be right. And let's go to the other extreme. Prefix 1s is 0, suffix zeros is 3. Yep, if we want all 1s, then these 3 zeros have to change, so that would be correct too. I don't know what is going wrong. Yeah, that's weird. Let me print prefix 1s and suffix zeros to see if it confirms what it should be. 0 0 1 2 5 4. That's wrong. That's wrong. Boom. I called it. J is a new indice. We run it, passed, and submit it. And boom. Okay, it's a bad runtime, bad memory, but for the interview, it's all you need.